Hi class, thanks for joining me today. Today we are going to do an activity that will help us find different representations of algebraic data. You should have a stack of papers where you have 6 pieces of paper that look identical to this, and you'll notice that it says Algebra 1 EOC Review Function Toolbox. And what this video is going to do, it's going to walk you through filling out this toolbox with the example problem. Our example problem starts with these 4 points, and even though this piece of paper might look a little bit intimidating, it's not something designed to start at the beginning and work till the end. You just pick what you think is easy at the moment and you just build on what you've done. For instance, I've got 4 points here, and I can tell already that making a table with these 4 points is something very straightforward and something I definitely know I can do. So let's start there because it's easy. So here we go. We take, you should be doing this too, by the way. I should not be the only one working. If I get ahead of you or go too fast, feel free to pause the video and catch up. So let's do our X and Y table. We've drawn a T-chart, and now we're just going to enter the points like I see them. Okay, and we've entered the table. It's as simple as that. Looking over here at the left, though, we know they want more than just the X and Y terms. We also want independent, dependent, domain, and range. Well, I know your teachers have been really good this year about teaching you the little story about Miss X and Mr. Y who went to the doctor but had no ID, so they couldn't be seen. So that means Miss X, she is our domain, and she is independent. Please write that out. It is important. And Mr. Y over here, he's our range, and he is dependent. And what this is doing, it's going ahead and just labeling all the data, so when you have that question on the STAR test that asks you for the domain, if you've made the table, you'll immediately know which one it is. Once I make this table, it reminds me of the fact that we've learned stat recently, and stat helps me come up with an equation for when I have a series of points, and it just does not want to be over there for some reason. There we go. So what I do is I'm going to use the stat function in my calculator, stat edit, and we're going to put the there we go. We're going to put the x values in L1, and we're going to put the y values in L2. And once again, if I get ahead of you, just pause the video and catch up. Okay, I've entered all 4 points, and now I hit stat again, calculate, and I'm going to use quadratic regression. Quadratic is a parabola, but if this line or if this data set is a linear function, then what's going to happen is that a is going to be 0. If it is a parabola, a is going to be some other number. So I've got, let me move my calculator. So I've got a equals 0. Let's write this down, and once again you should be following along with me. B equals 1.25 and C equals 3. So that means y equals 0, x squared plus 1.25 x plus 3. I like when I have zeros multiplied to variables, because then I know that it's going to equal 0 and that it doesn't change the value of my equation in any way, and I can just get rid of it. So I'm going to rewrite it now. And so now look what we've done. We have written an equation, and we put it both in f of x notation, which is function notation, and y equals notation. I wonder why I put 13 over there. Y'all ignore that. So what I know from here is that my slope is 1.25 and that my y-intercept is 3 because it's in slope-intercept form. Let's keep going. Like I said, we just wrote this down. And so wanting my intercepts, I know that my y-intercept is 3 just because of the equation. And if I forget that, I can also use my calculator and put this equation in y equals, and we're going to put 1.25x plus 3, and then I'm going to graph it. And if you'll notice, I think it goes through 3 exactly, and then maybe not quite a whole number over here. We can always look at a table of points. Oh, and right there, look, x is 0 and y is 3. So that's definitely my y-intercept. The next thing I can do is I can look for a 0 over here to find the x-intercept. Well, I'm not seeing one, and in fact I see it go from a positive number here to a negative number here, so I know that 0 should be right in there somewhere. So that tells me that I'm dealing with a decimal. And I'm okay with that because I know how to solve for intercepts. So let's see what we can do. We're going to have to do a little bit of algebra, so anywhere on your page or on a scratch sheet of paper, anything you've got handy. We are looking for x when y is 0. That's what the x-intercept means. So I know this is y, so I'm going to substitute it for the y in my equation. I'm going to find my 0 pair here, and I'm going to subtract 3 from both sides. This zeroes out. And then I've got negative 3 equals 1.25x. My next step, divide by 1.25, divide by 1.25. And I'm always going to use my calculator where I can, just so that I don't make silly mistakes. I've been doing math for a lot of years, and I still make silly mistakes. So I try to use something that I know is going to be right. This says my x-intercept is negative 2.4. So let's write that. X equals negative. Okay. So now let's go back to our piece of paper and let's fill this out. Negative 2.4. So there's my x-intercept and my y-intercept. And if you'll notice, it asks for a numerical value and it asks for a verbal explanation. The verbal explanation would be that my linear function crosses the y-intercept at 3 and it crosses the x-intercept at negative 2.4. I don't have enough room to write that, but on the next ones you'll see that it's even more important that we get that down. Looking here, the next thing I want to do is to find out which one is the parent function. Is it linear or quadratic? And then I want to sketch not only the parent function, but I also want to sketch the actual graph. We know it's linear, so let's go ahead and let's graph the linear parent function. And you know on the STAR test, it will give you some data points and ask you what is the parent function of those data points. And to find out, you've got to use stat. You have to do exactly what we just did. So already we've answered 4 or 5 questions that could possibly have been asked with this data point. The next thing we're going to do is we're going to sketch the actual function. And we know that the intercepts are 3 and negative 2.4. And so all I really need to do is connect those 2 points, draw my line, put the arrows on the end, pretend that that's straight line for me, please. And I've sketched the graph, and I've also found the parent function. And we know that this parent function is linear. There's only one more thing left of this page, and even though it's taken us a while, it's all very straightforward. It's nothing that we don't know how to do. The next thing, the only thing left, is to find the slope. And we know from our equation, we know that our slope is 1.25 because it's in slope-intercept form. This is the slope. and this is the y-intercept. Well, I don't necessarily like having a decimal for slope. It's not as descriptive. It doesn't help me as much as a fraction does. So let's put in our home screen, let's put 1.25 in our home screen, and then let's put 1.25 in our home screen, and then let's do math, and we're going to turn it into a fraction in our inner. And so it is m equals 5 over 4. And remember, I know your teachers have told you that it's the change in y over the change in x, and our numerical value is 5 over 4, but our verbal explanation is that y changes by 5 every time x changes by 4. And since these are both, since this is a positive slope, that you know y increases by 5 every time x increases by 4. I know it's been lengthy. Thank you guys for hanging in with me. You guys try the next one on your own, and if you get stuck, there is a video in Schoology to help you. Thanks for your time, guys.